Our guest today has made great contributions to the Christian Research Journal. His name is Fuz Rana. He is president. He's the chief executive officer of Reasons to Believe, an incredible ministry. He has a PhD in chemistry. He's the author of many different articles, as I just mentioned, some of which have appeared in the Christian Research Journal. He's the author of quite a few books, but the book we're really interested in today, and a book you have to read. I mean, this is cutting edge stuff. Humans 2.0, subtitled Scientific, Philosophical, and Theological Perspectives on Transhumanism. What's great about this book as well is you get into some very complex issues. You mentioned gene editing, and you warn the reader, this is going to be heavy-duty material. It might take a while to slog through this. Maybe you want to skip ahead, and you can do that without losing the sense of this book. But let's talk about gene editing for a moment. What is gene editing? And also, I want you to touch upon the complexity of gene editing in the sense that it not only affects an embryo at a particular stage, but it will affect the lineage of that embryo in perpetuity.
Yes. Yeah. Gene editing has been the dream of medical doctors and geneticists for probably a good 50 years, maybe even longer than that, with the idea that, look, many human diseases involve genetic defects. There's mutations that have taken place that introduce genetic defects in our genome. And in fact, there's probably somewhere between 5,000 to 10,000 diseases that are of genetic nature that involve a mutation in a single spot in the genome. Many of them are rare. There's not really any kind of treatments for them. And maybe about 10, 15 years ago, a researcher at Stanford University invented this new technique for gene editing called CRISPR gene editing. And it's a very powerful way to alter genomes of organisms, including human beings, with a high degree of precision. It's very easy to use. It's very inexpensive. It literally is revolutionary. And since that time, people have developed all kinds of different variations of the technique. But we now have a toolkit where we can literally go in and alter the genetic makeup of any individual in precisely the way that we would want it to be altered. This is going to revolutionize medicine in terms of treating genetic disorders again, and maybe even curing people that have genetic diseases. In fact, about a year ago, there was a small-scale clinical trial involving about 40 people with sickle cell anemia, and using CRISPR gene editing, they cured 75% of the clinical participants of sickle cell anemia. That's absolutely unheard of, right? To have that kind of success. So this is a reality that's increasingly upon us. It's a very even though it's a very simple technique to use, there's a lot of complications that prevent it from moving into a clinical setting. But it really is a very powerful technique, again, that will change medicine in many respects in good ways. But that same technology now can be used to create designer human beings as well, or even to modify human beings so that we're stronger and maybe more intelligent or more psychologically well-adjusted. At least that would be the vision that some people have of gene editing. But when it comes to gene editing, you can, for example, with sickle cell anemia, what you're doing is you're gene editing particular cells that would be found in bone marrow so that they now produce healthy red blood cells. But you're not really altering the genetic makeup of that individual. So if that individual has a child, that child very well could have sickle cell anemia. The gold standard would be to do gene editing at the embryo stage, right, where you are making that genetic correction in the embryo. So then when that embryo grows and develops, that genetic defect would not be part of the individual's makeup.
Or the lineage of that individual.
That's exactly right. But, there's all kinds of problems with this because you've got to do genome screening of the mother and the father. Then you have to then basically do gene editing on all the embryos that you would generate through in vitro fertilization. Those that weren't successfully gene edited would be destroyed. So there's a lot, it's gruesome in many respects. I mean, that is the cost. And if you happen to do the gene editing in such a way that not only you correct the genetic defect, but maybe introduce other genetic changes that you're unaware of, as you said, when that individual reproduces, that genetic defect is now introduced into the human into the human gene pool. And so that in and of itself is deeply concerning. So, there are ways in which this technique can be used that raise minimal ethical issues. There are other ways the technique that can be used that even in a medical context raise just horrendous ethical concerns. And then when you start thinking about enhancements, you are in a completely different ethical regime at that point.